1 over a squared plus x squared looks a lot like the derivative of arctan of x, and indeed, the integral of this thing is going to give us an arctangent. As you may recall, the integral of 1 over 1 plus u squared is arctan of u plus c. The key difference right now between this familiar formula and our integral is that in the formula there's a 1, whereas we have an a squared. So let's take out an a squared to turn this into a 1, and then go from there. Taking the a squared out in the denominator leaves 1 plus x squared over a squared in these parentheses. Then we can take the 1 over a squared out of the integral and rewrite x squared over a squared as x over a all squared. Now it's starting to look a bit more like the familiar formula. We just have to apply u-substitution. We'll let u equal x over a. That then gives us that du, taking the derivative of both sides, equals 1 over a dx. Remember, a is just a real number, so 1 over a is just the real number coefficient of x over a. Now, in our integrand, we don't have a 1 over a, we just have this dx. So let's multiply both sides of this equation by a so that we find dx equals a du. Now we can rewrite this entire integral in terms of u. Doing that, we still have the 1 over a squared outside the integral, and then inside we have 1 over 1 plus u squared, and then dx gets replaced by a du. We can then pull that factor of a out of the integral, which will cancel out with a factor of a in the denominator of that coefficient we have, leaving us with 1 over a multiplied by the integral of 1 over 1 plus u squared du. Now, this is exactly the arctan integral formula. So, this is equal to 1 over a multiplied by arctangent u plus the arbitrary constant. Finally, we can replace u with what we set it equal to get our answer in terms of x. 1 over a arctan, which remember is the inverse tangent function, and then u is x over a. So we'll just replace it with x over a, and don't forget the plus c.